Okay, so question 18. Now, before I go on, part 3 of this question requires you to do relative velocity, so I apologize. You can ignore 18 part 3 until we've done that topic, which will be after Easter. Okay, so apologies for those of you who struggled with 18 part 3. But the easiest way to do it is relative velocity, so that's what we're going to do. So we can ignore that for the moment. Okay, so the rest of 18 though. A small smooth sphere moves on a horizontal floor speed 2u, strikes an identical sphere lying at rest on the floor at a distance 1 meter from a wall, the impact being along the center is perpendicular to the wall. The coefficients of restitution of all impacts is E. Prove that the speeds of the spheres after the first collision are. Okay. So we have 2u. We call the mass m and m because they're identical. Okay, and then p and q. So Newton's law of restitution. P minus q over 2u minus 0 equals minus e. P minus q equals minus 2ue. Momentum 2u by m plus 0 by m equals p by m plus q by m. So 2u equals p plus q if I divide across by m. So put p plus q under this one. Okay, 2p then equals 2u minus 2ue. Divide across by 2 and factorize out the u. Okay, find q, sub it back into one of the two. Okay, so q equals for here 2u minus p, so 2u minus u minus ue is u plus ue, which is u1 plus e. Okay, as asked. All right. Now, the next bit's a bit tricky. Okay, so the second sphere hits the wall when the spheres are a distance of 2e over 1 plus e apart. Okay, so the first thing we need to work out. Oh, that's for 19. Apologies. Okay, the first thing I need to work out is so it's speed q. This one is going to hit the wall. Okay, now we want to know what distance they are apart. So the first thing I want to do is work out how long it takes this one to hit the wall. Okay, so you imagine this mass gets hit, it takes off now u times 1 plus e velocity, and then it travels a distance of 1 meter. So the first thing to work out is the time that takes. Now time is distance over speed. The distance is 1 meter, and the speed is u by 1 plus e. Okay, and that's seconds. Now, the distance traveled by this sphere in that time, distance of q, okay, is speed times time. Now, the speed of this p, right, is u by 1 minus e times 1 over u1 plus e. Okay, u goes into u, and I'm left with 1 minus e over 1 plus e. That's how far, meters. That is how far this sphere here has moved in this direction since the collision. Okay, now, how far from the wall is that? Well, the wall is 1 meter from the collision, so it's 1 meter take away 1 minus e over 1 plus e. Now, how do I take this apart? I'm going to turn 1 into 1 plus e over 1 plus e. So that becomes 1 plus E minus 1 minus E over 1 plus E. Okay, because it's just adding fractions with the same denominator. 1 minus 1 is 0, and E minus E is 2E over 1 plus E as asked. Okay, like I said at the beginning, 18 part 3, we're going to use relative velocity. Okay, so you don't need to worry about that. Now, question 19 looks like this. Okay, so sphere of mass 0.6 kilograms attached to the end of a string, the other end being attached to a fixed point. The string is half a meter long. The sphere is released when it makes an angle of 60 degrees. The sphere collides directly with another sphere of 0.8 kilogram, which is hanging vertically. E is 1/11. Find the speed of the 0.6 kilogram sphere just before the collision. Okay, so what we're going to do is we're going to look at energy here and energy here. Okay, what's the potential energy here, and what would its kinetic energy be when it gets to here? That will be equal, and we'll be able to use that to work out velocity. The first thing I'm going to work out is what height is that going to be above. Okay, so to work that out, get rid of that 0.5. The whole thing's 0.5. Okay, I'll write down. Okay, the whole thing's 0.5. So how do I work out h? Well, I can work out this. Okay, because I have 0.5 and I have 60. So I'll just call this x. Okay, so cosine 60 equals x over 0.5. So 0.5 by cosine 60 is x. Okay. Now, what does that get me? I'll calculate it back in degrees. Which is a quarter. So x is 0.25, so that means h is 0.5 minus 0.25, which is also 0.25. Apologies. Okay, so potential energy will equal the kinetic energy at the bottom. Potential energy at the top is mgh, and the kinetic energy at the bottom is a half mv squared. So I'm looking for v. So 0.6 times 9.8 times its height is 0.25 equals a half times 0.6 times v squared. Okay, now there's 0.6 on both, so you can divide across by 0.6, so 9.8 times 0.25. So this side becomes 49 over 20 equals half v squared. So I get 49 over 10 is v squared. So v is the square root of that. 2.21 meters per second. Okay, now you can leave that as this would have been root g over 2. Okay, if you'd left this as g, okay, if you'd left it as g, you'd have g over 4. G over 4 is a half v squared. So that becomes g over 2 equals v squared. So v would be root g over 2. Okay, so that's what we're going to use from the second part. So the speed of each sphere just after the collision. Okay, so the speed of each sphere just after the collision. So before, mass, after. So the 0.6 and the 0.8. The 0.8 is 0, and then I'll call it qi. This one I don't know before, after, but before it's root g over 2. Okay. Now, I'll keep it as root g over 2. Or you could do the 2.21. It's not going to make that much of a difference probably at this stage. But anyway, so p minus q over root g over 2 minus 0 equals minus an 11th. So p minus q is, and to be honest, I think I'm just going to use the 2.21 in this instance because it's just going to make my life a lot easier. 2.21 times 1 over 11 is 0.201. Okay, and minus. For momentum, 2.21 by 0.6 plus 0 equals 0.6 p plus 0.8 q. 2.21 by 0.6. So 1.326 equals 0.6 p plus 0.8 q. Okay, so I'm going to do simultaneous equations. P minus q is 0.201, and I'm going to divide this one by 0.8. So 0.6 divided by 0.8 is 0.75 minus p minus plus q divided by 0.8 is q, and 1.326 divided by 0.8 is 1.6575. So q is equal to 0. I got 1.75 p equals 1.6575 plus 0.201, 1.8585. So p is divided that by 1.75, 1.062. Oh, we're a bit off there actually. Okay, apologies. This was supposed to be negative. I didn't see the negative there. So when I add 0.65 minus 0.201 is 1.4565. Okay, when I divide that by 1.75, I get 0.832. Now, I think it's 0.84 on the back of the book, which shows I'm a decimal point off by rounding. Okay, so maybe we won't be lazy in future. We'll do root g over 2 here and keep our answers nice and accurate. Okay? Then to find q, sub in for p. Alright, so we can all do that.